Welcome and thank you for joining. We'll take a look at another textbook question from page 83, number 18. We have to determine the value of a, given that the line ax minus 4y plus 21 equals 0 is tangent to the graph of y equals a over x squared at x equals negative 2. Let's examine the question more closely and try to write the information down in the meantime. So it seems that we are given the equation of some function in the form y equals a over x squared. We are drawing a tangent line on the graph of this function exactly at x equals negative 2. The equation of this tangent line is ax minus 4y plus 21 equals 0. As you can see in here, we are given two equations, the equation of a function and a tangent to the function at x equals negative 2. Now recall that whenever we draw a tangent line on the graph of a function, the point of tangency is a common point to both the graph of the tangent and the function. What that means is that the x and the y coordinates at the point of tangency must satisfy both the equation of the function and the equation of the tangent. So this is the point that we are going to use to solve this problem. And we can approach solving this problem in two different ways. We're going to start with the first one. So the first method is about using the equation of the function to determine the coordinates of the point of tangency and then take the coordinates at the point of tangency and substitute them into the equation of the tangent to identify a. So what that means is that since x equals negative 2, we'll use the equation of the function y equals a over x squared and evaluate it exactly at the point of tangency, which is at x equals negative 2. And we'll get that the value of y is equal to a over 4. So y is a over 4. So we'll say that x equals negative 2, y equals a over 4. Since it is a common point to both the tangent and the function, must satisfy the equation of the tangent as well. So we'll bring x equals negative 2 and y equals a over 4 into the equation of the tangent line, and then try to solve this equation for a. Let's see what we get. So we have a, instead of x now we have negative 2, and then we have minus 4, instead of y we have a over 4, and then plus 21 equals nothing. So simplify, negative 2a, you see negative 4 and 4 will simplify to negative 1, so negative a plus 21 equals 0. Combine the a terms together, so that's negative 3a. Bring 21 to the other side, that's a negative 21. Isolate a, and we obtain the value of a equal to positive 7. So a must be 7 for the tangent line to be drawn at the point where the x value is negative 2. Now, as I was explaining before, we can solve this problem in two different ways. So we can find the point of tangency by using the equation of the function and then substitute this into the equation of the tangent. But we can also go the other way around, which I'm going to show here. So I am going to use the exact same information as we did before. So equation of the function, tangent, point of tangency, and the graph. But this time I'm going to reverse my thinking. So I am going to use the equation of the tangent to determine the point of tangency. So if we said that the point of tangency is common to both the tangent and the function, so x equals negative 2, that's a given. And now we'll grab the value of y from the tangent line, which means that we have to substitute x by negative 2 here. So that will give a times negative 2 minus 4y plus 21 equals 0. So we are solving for y in here because we're trying to find the value of y. So we're going to make that obvious in the next step. So we're going to have here negative 2a minus 4y. Here we go. Let's make this red now. Plus 21 equals 0. So we're solving for y, which means we're leaving y on the left side. And negative 2a will come to the other side, become positive. And 21 will come to the other side, become negative. So isolate y. We have 2a over negative 4 minus 21 over negative 4. Simplify, and we get y equals negative 1 over 2a plus 21 over 4. So using the tangent line, we figure out that y can be expressed as negative 1 over 2a plus 21 over 4. So we'll take the equation or the coordinates of x and y that we identified by using the equation of the tangent, substitute it into the equation of the function. Let's see what we get here. So now the value of y will be replaced by negative 1 over 2a plus 21 over 4. The other side, we have a, and we have x to the power of 2, and the x value is negative 2. So let's continue solving. So as you can see here, we have negative a over 2. I'll write this as a single fraction because it's easier to use this in solving the equation. Plus 21 over 4 equals a over 4. So you see that the lowest common denominator here is 4. So we'll eliminate the denominator by shooting every function with every term with a 4. So that will give 4 divided by 2, a 2 times negative a, negative 2a. And then this will become simply 21. And on the other side, we have again 4 and 4 simplifies to a. So negative 2a minus a equals negative 21. So negative 3a equals negative 21, and as you can see, we obtained the same value of a. So we could have gone, we can go either way. So use again the coordinates of the point of tangency by using the equation of the tangent and then substituting it to the function, or we can go find the equation, coordinates of the point of tangency using the function and substitute it into the tangent, because the point of tangency belongs to both of them, and it doesn't matter which way we go as we substitute the points, the coordinates of the tangency, point of tangency. So I hope that this made sense, and try to reproduce the solution in your own way, in your own terms. There is a third way of approaching this problem, and I want you to think about it. We'll discuss it in class as well, but it would be very interesting to hear how you can see the solution to this problem as well. Well, thank you for learning with me, and bye for now.